Okay, hi everyone. So this is, you've already designed your tower, so your wind turbine is finished, you've already designed your blade. Now it's the time to test it for performance, which means we're going to have to find out what the power generation is, and also we're going to check it for stiffness, see how far your tower actually bends. So what you're looking at here is basically all the equipments that we have that you need for here. There's a blower, right? That it gives you about 25 miles per hour speed. There's a stand here, and you have the meter there, the same one that you use for solar, and you have the load box here. Now this load box is just basically a potentiometer. So all it does is basically draws power from your wind turbine as you're generating the wind turbine. Then you have a little measuring device here to measure the wind, and I'll show you how you can actually use this, right, on both sides. You basically press it, it comes on, and as the wind hits it, it's going to register the speed. In order to actually measure your speed, we also have a tachometer here, right, that measures your speed, and I'll show you how to use this one. All you do is basically just press the button here. As you're holding it, you can see that it actually puts a laser on, and we're going to put a reflective tape on your blade so you can actually measure that. Okay, so how does this work? So the first time you come here, you basically pick up your tower. So here's an example of the tower that was designed by you. This is a 3D printed tower here, so it was actually nicely designed. You go ahead, and we have studs coming out, 4 corners here, so you make sure that this hits or sits exactly at the right place, fits perfectly there, and we have some butterfly nuts here, but 4 of them. You go ahead and tighten all 4, so your tower is pretty stable. Now usually you don't have a problem with the tower, it really doesn't go anyplace, but you still should put this on it. Now if one of the other things you have to do is you want to make sure that actually your blower, you remember we told you guys that the height of this should be about 17 inches, that brings it out to the center of the tower here. So we want to make sure that you're getting the whole benefit of the 25 miles per hour that is hitting your blade. If you need some adjustment, you can actually put something underneath the blower to bring it up a little bit, and you can make that adjustment in there. So the next thing you do once you fasten this one is you take your blade here, and when you're looking at your blade here, normally the way you've designed here, that one direction gives you a really nice lift and the other direction does not. So that's the first thing you want to do, is find out what is the right, correct direction for that. You go ahead and install it and you find out, right? So I'm going to go ahead and use one side of this, just put in, make sure there's a D-shaped size, right? A hole on it, and that D shape should basically match the shaft that you have here. So once you put it in, then we can go ahead and try it out.
She just walked behind you.
Okay, the D size is correct. I go ahead and put it in. So there's the blade installed, right? Make sure again that it's not hitting your tower as it's rotating in there, right? So we're ready to go. I'm going to go ahead and turn the blower on. It's on this side here. Move again, move slow.
Okay.
You go ahead and turn the motor on, and you can see that it's rotating. Notice nothing is happening. This is about 25 miles per hour it's hitting it, and this is known as a stall. This happens because the direction of your twist or your angle of attack is wrong. And so all you have to do is that you pull it out, you turn it 180 degrees basically, and you put it back in there again, and make sure that you're matching the D-shaped size. This is actually not as easy as you may think, because you don't want to press it too hard and actually cause breaking, the shaft. It basically pops in when it's there. Now I'm going to go ahead and turn it on and put it on a high and maximum here, and you can see so this is the right direction over there. Now I'm going to go ahead and stop that. One of the main things, of course, is the future. Notice that I didn't have my goggles on. So before you get started, you put your goggles on. We only worry about your eyes, basically. If this comes out, is basically the blade comes out in a direction of which is perpendicular to the axis of rotation of the motor. And so you just don't want to kind of stand right in front of that. It may, if it does come off, or if it breaks, it's going to hit you in the body, which is not too bad actually, but you just don't want you to get hurt, in the eyes in there.
Leave them on.
So the next thing is I'm going to leave my glasses on, as you can see. So now once it's installed, the next thing is you decide, now that you found out what direction is correct, you can decide the person. One of you guys is going to be actually measuring the speed of the rotation, the RPM of the blade. So you stand back here and you aim your laser, right? You aim your laser that it hits the tape. Notice that there's a reflective tape on the blade in here. Now, once it hits the tape, of course, you know, it measures the RPM and somebody is going to read the RPM as it's rotating. I'm going to go ahead and take one quick sample here so you guys can see what I mean by the RPM. I'm going to go turn it on and this is the aim of the blade. That's it. And you're going to hit the RPM. So this is about 11,000 RPM, which is pretty good. We'll go ahead and stop that. Now, once you've decided that, the next thing is that we want to make sure that you're actually getting 25 miles per hour speed here. So you go ahead and take the blade off, right? We don't want the blade on it while you're doing this because there's a chance that you may actually accidentally hit the blade and which may cause, you know, damage to the blade here. So you go ahead and turn the blower on, right? You go ahead and press the zero so you can actually see that. So it's not on the zero here. We're going to go ahead and bring it in and hold it fairly close to the center of the shaft. This is going to make sure that you're not in the front because you're going to block the wind. So right over here, and somebody on that side is going to read the number here. For example, I'm looking at this particular one about 25 or 26, so that's pretty good. Now once you have this, then and if you have to make an adjustment, you do. You can move the table forward, you can move the table back till you actually get about 25 miles. 25 miles per hour is not going to be exact, so 24 and a half, 25 and a half is fine. Whatever you're in that range, work with it. Now once you've decided on that, you're going to go ahead and turn that off. So we're all set to start the test. We need a tape. You get one of these reflective tape, have your lab instructor cut a small piece for you, and you go ahead and put it kind of in the middle of the blade. Right? Make sure that you use your fingers to make sure that it's tight. Remember, this thing is going to be rotating at about 8,000 RPM. So if there's part of it that is not sticking to the blade, it's just going to come off fairly quickly. Right? So once you've decided on that one, now you can put your blade back. Now notice that I have the tape on it. Right? I go ahead and put the blade back in. Right? That usually, be patient with this again. Make sure that your D shape matches the shaft. Actually the motor on the shaft here, so actually you can rotate it freely here. So we're ready to go. The only thing is that you're going to have to turn the equipment on at this stage. So I'm going to go ahead and turn the meter on. This is the same meter that you use for solar. Notice that the same dial, the digital dial here, is going to read the voltage first for you, and then it's going to read the current, and finally the product of these two should be your power. Right? So as you can see now, everything is on the zero. Now, at one point, you're going to have to attach this to the generator, right? So this side of the meter, you remember, like the solar project that you guys did, this is the input that is coming in. In your solar, you had that power, the electricity produced by the panels coming through here. Here is going to be by the wind, by the blade here and the wind, your wind turbine. So this would be your input. Your output here, we have it going through the load box. As it goes through the load box, this acts like a potentiometer. It's a kind of fancy looking potentiometer that you use a more primitive one actually with the solar project. So now we have everything is set up here. What you want to make sure is that you turn this one on and put it on a no load. Right, this is on a no load here. I'm going to go ahead and fasten this one or connect it to the motor here. Again, red to red. Make sure that you're making contact with the bare side of the wire here, so you're actually getting connection good. And again, let's see, there you go. Also make sure that they're not touching each other. If they are touching each other, it's going to stall for you. So we're ready to go. Everything is really reading zero on this one, and I'm going to go ahead and try. Oops. Go ahead and turn it on and show you the first power that you get. So as I turn this one up to high, right, you're going to start reading. I noticed that on the meter here, you're reading about 6 volts. This is actually a nice plate. So it's giving you about 6 volts here, but there is no current and no power is being drawn from it. Because it's really, the load cell is still not working good. I'm going to go ahead and put that one on a variable load here, right? And start turning this. Notice the light is coming out, the RPM goes out, and you can see the numbers are changing there, right? Your power starts going up to 1 watt. Your voltage is dropping and the RPM starts going down. You can actually hear it as it starts going down, right? And that's pretty much it. So now what you want to do is find the peak power on this on the blade that you designed, which means you rotate this knob till you actually see the power in there. Let me go ahead and change the direction here. Right. So this is a fairly good blade. It's actually giving you more than 2 watts. Don't worry about the sign on this one. If that bothers you, this negative, just switch the wires here. So I'm going to go up. I'm going up 2.3, 2.3, 2.4, 2.5. Notice that I'm kind of reached the peak, is going down. So this can give you about 2.5 watts of power here. Now, as it's going down, we want you to get points. So you have about 10, 12 points here, starting all the way to the left here. Notice that I'm back to the maximum voltage here, no power drawn here, right? And the lights are just basically for the demo. You can see the LED lights come on. So I'm going to go ahead and start cranking it up. Make sure that you have the increments in there. So about 10 or 12, you reach the peak and you start declining. So as I rotate this one, notice that it's, again, the RPM goes up. If you're looking at the power, it's 1.6. It goes to 1.8, 2. And then you remember this reached about 2.5, and then it started going down. Now it's going down, right? So if you get a couple of points after it starts going down, that's enough here. Right? We want to reach the peak. So the peak of this one was 2.5, and you take the data down, right? And then once you've done that, I'm going to go ahead and turn everything off. Again, this is what I was saying. So make sure you're not really standing in this direction where I'm standing here. Because if this comes out, it basically comes out this way. I'm going to go ahead and stop that and stop screaming, really. So now we're pretty much done with the experiment. Now, if you're not certain, you can repeat this one a couple of times and make sure that you get the power that you need. I'm going to go ahead and take my goggles off and now go to, so this was the power generation. You have a data sheet. You want to make sure that you actually fill that data sheet as we go. So maybe about, again, as I mentioned, about 10 to 12 points is enough. So we don't want to be that, it doesn't have to be that accurate. So long as you reach a peak here, as you climb up here, you're going to go reach the peak and start going down. We want to find that peak, right? And that's the one we're judging. If you get over 2 watts, that's, you get the maximum points basically for performance of the power. If it's a little bit less than that, then of course, depending on how much less it is, then you have the rubric that is on canvas. You can take a look at that. Maximum you're going to lose maybe 6 or 8 points. That's it, out of the 30. So 30 points, goes to this one now. So this is the power generation experiment. Right? Let's go ahead and go to the next stage here. This is for your stiffness. The stiffness also goes, this one actually a little bit faster here. We have the same type of a stand for the stiffness. You can see that, again, the blueprint. Let me go ahead and get the tower and bring it over here so we can see, you can stay there. Okay, so this is the same tower. The only thing that is different in it is that we have this the screw in the back here, right? This is known as the eye bolt here. So we have an eye bolt here. Attached to that is a string, right? And we're basically going to pull at your tower and test how far it bends, right? So again, the setup is the same. You fit it on the test bed. This is exactly the same as we have for the power generation, right? Couple of things in there. There's no need for you to have the blade in there anymore. I'm going to go ahead and take the blade off because we're done with the power generation here. And now the first thing you want to do is pass the string through the hole that you have here and then go over the pulley, right? So I'm going to go ahead and push that through here, catch it from the other end, and whoops, it cut out on the meter. So then put it on the pulley and have it dangle on the underside, right? So you can see what's coming up. You have weights here on the table here. The 100 grams, right? Then you go into 200 grams, and then you go into 400 and 500 and so on. The first test that you're running, we're just going to use the 100 grams one. And you're going to be using 10 of them as we go through them. So you go ahead and set up the meter first. Now this is the dial measuring, the deflection here. I'm going to go ahead and bring it up. So it's nudging against the back, pushing it in a little bit, right? Till it actually is pushed in, right? As it gets pushed in more, of course, it's going to register that, right? You go ahead and turn it on. I think it's already on. No, it's not on. So you go ahead and press on that one, it comes on. Once it's there, you go ahead and zero that, right? So this is your zero position. One of the best, first thing that you should realize is that this is very sensitive. This tower is not going to deflect more than a few millimeters. Now, in order to make sure that you're getting accurate numbers, you don't want to lean on this disc. You don't want to touch the stands, because the moment you touch it, or even if you jump up and down here, you're going to get a little variation on the reading. So once everything is zeroed out here and this is attached here, there's a magnetic, this device actually, it locks in into the metal table you have here. So there's a dial here, you can actually turn it. If it's loose, it can move, right? The moment I lock this one up, now you're going to actually clamp down the place that you have here and make sure that it doesn't move. Your lab instructors, by the way, they're all going to go through this process with you. This is kind of getting you started on that one. So once everything is set up here, all you do is pick up, there's a 100 one, right? So I'm going to go ahead and loop the 100 over on this side here, right? Just there's a loop at the end of this rock, and you read the number. You record the number. This is for 100 grams of the force. Then without taking it off, this is very important, because normally when you take it off, it should go to zero, but it doesn't. It doesn't go back to zero because there's a lot of what we call the hysteresis in all the materials you're using here. The wood is kind of gives a little bit, even the plastic gives a little bit. So you want to continue. So once you have the 100 in there without lifting it up, you go ahead and there's a hook in the back here, and you can latch it, another 100. Then you need another number here, right? Then you go ahead, put the third one in there, right? Notice that I'm not lifting it up, I just basically add the third one in there. This way you avoid resetting it. If it happens that you want to take this thing off and you've done something wrong, you start over again. This, by the way, shouldn't take you more than 15 minutes to do. So you put 10 of these guys, this gives you 1,000. This is all you need to find the stiffness of the part here. So you don't need to do anything else. You do all the 10 here. Once you're done with that and you're anxious to find out what it takes to, let's say, peel off your tower or break some of the parts, you can go ahead and put the 500 in there, or even 1,000. I've had some of the students to go all the way up to 5 kilograms on this thing, and nothing happens. What is going to happen, actually, this string is going to break on this one. So if you go too high, your tower is fine, but your string is going to break in there. So that's pretty much it. This is for the stiffness. Once you've done the tower, I would do the power generation first, just in case there's something wrong with your tower that it's going to break. You want it to break with the stiffness. So you've already done your power transmissions, your power measurements. Okay, guys, so that's basically it. When you come into the lab, get started quickly. The 2 people who are here, obviously the rest are going to be on the Zoom. Everybody on the Zoom should watch the video, right? So you have an idea as to how to do the experiment. This way, it goes much faster. And then you make suggestion, hey, you're doing something wrong for the 2 persons that are here. Hopefully we get at least 2, possibly, sorry, at least 1, possibly 2. In my section, basically, we have 7 people showing up, you know, for, so 1 group had 1. But I'll be here, the lab assistant is going to be here, and we can help you with the setup as you're having a problem as you go through it. Okay, guys, so hopefully this helps you with the experiment and speed things up as you go through it. There are a lot of other nuances with this experiment that your lab instructor will describe that during the lab. Okay, have fun and be safe. Thanks.